Analog versus digital. In electronics, what is the technical difference between analog and digital circuits? You came to a good place because I'm a very technical person. Name's Electrocytec, so I will answer that technical difference question. Now, before I really begin to, most digital circuits, the wires, they do contain analog circuits. But what really makes the difference is, you could have one wire that is, 1 volt, and at another time that same wire could be 3 volts, and it could be 4 volts at another time. But what makes the difference here is that you have a standard, and that's usually set by an electronic component that is either switched on or off by that voltage, by that threshold. And whatever that threshold is what makes the difference between calling that wire on or off. 1 representing on, 0 representing off. So it's a standard. That's the bottom line here, is it's a standard. Now in our temperature sending example, communicating this by analog and digital, we do want to know what the range is, and that's going to be 0 degrees to 100 degrees. Which scale you use doesn't really matter. Bottom line is we have numbers 0 to 100. That's cold for Fahrenheit, and that's hot for Celsius. So, hey. All right, so in our case here, if we're going between 0 and 5 volts on the analog, that portion between the parameters for the temperature and the parameters for our voltage will leave us with about 1.85 volts to communicate 37 degrees. So our sending unit would send 1.85 volts. Our receiving unit would receive that 1.85 volts, and it would move, say a needle on a gauge, or maybe convert it to a digital signal. But it's going to expect that 1.85 volts to mean 37 degrees. It's going to point at the 37 degree mark, or convert it to 37 in digital. Now let's take a look at what digital says. That same 35 degrees, you can use any number of bits. More bits means the more accurate. So, the temperature here being 37 degrees, and I came up with the bits 0, 1 to represent this. And everything that is represented by 0, 1 would be read out as 37.5 degrees. Now the way I determine this, the way a circuit would determine this, is your first half of 0 to 100 of your threshold is going to determine your first bit. And it's going to make it's digital. It makes true and false decisions. Everything is 1 of 2. It's binary, true or false, on or off. And it's going to turn that first wire off if it is below your center threshold, if it's below 50 degrees. So it is, and therefore it is off. It is not over 50. It is 0. It is off. Now, with the second threshold, is going to be at 25. That's half of what you have left. Between 0 and 50 is 25. Is it over 25? True. Which means 1. We just turned that on. And then the average in there is what I'd be reading this out as. The average between 25 and 50 is 37.5. So if I was actually going to build a reader for this and read this out in human language, 37.5 would be pretty accurate. But everything between, everything that registers on that 25 degree range to, to the 50 degree range, whether or not you count those just depends on how your system's set up. But anything in that range is all going to be read out as 37.5. So if it's 26 degrees, it still shows it as 37.5. You fix that by adding more bits, more decisions, splitting it into more, splitting that range up further. So that's the main difference there between analog and digital. Analog usually works pretty well, and you can really define some good numbers in there. If I wanted to add decimal points onto this degrees, I would just make this a finer number down here. Digital, I can add more bits. Digital works great for a lot of things until it doesn't work at all. When it quits, it quits. It oftentimes uses a timing, and once that timing doesn't work or anything else goes wrong, it is just going to straight fail. As opposed to analog might try to work, but digital, if it's not perfect, it gets rejected. Thank you for watching.